In this video, I want to demonstrate a few examples where we will transform graphs of functions when we are given only the graph and not the explicit function. So the graph of y equals f of x is shown, and we want to draw the graph of g of x, which is equal to f of x plus 3 minus 2. So we need to understand what these transformations mean. We have an inside change and an outside change. The inside change of a plus 3 means that the graph will shift left 3 units. And then the minus 2 tells us that the graph will shift down 2 units. And remember that we have to do the changes that impact x first, so we'll shift left and then down. When we're given a graph, we need to identify points on the graph and then move each of those points to the corresponding point on the new graph. So I'm going to first identify some points on this particular graph. This is a piece that consists of 3 different types of functions all joined together. We'll talk more about this type of graph later. It's called a piecewise defined function. But note that we have to the left of -1 of x equals -1, it's a line segment or array really. And then we have part of a parabola, and then we have part of a horizontal line. So some key points on this graph of f are -2, -3, -1, 2. So the -1, 2 is the endpoint of this ray, and then it goes down through the -2, -3. Then we begin the parabola at this -1, 2, and it goes down through 0, -1, and 1, -2. And then the parabola turns back up to the point 3, 2. And then beyond the 3, 2, to the right is just a horizontal ray. That is, it goes through the point 4, 2, 5, 2, and so on. So now to get the transformed graph, we need to shift each of these pieces left 3 and down 2. Now if you want, remember that that means for each of the values, if we have a point x, y in the graph, the new point has to be x minus 3, y minus 2, right? Our x will decrease by 3 and our y value will decrease by 2. So I'm going to take -2, -3, shift it left 3, so 1, 2, 3, and down 2. And that takes us to the point -5, -5. -1, 2 is left 3 and down 2, takes us to -4, 0. 0, -1 goes left 3, down 2 to the point -3, -3. 1, -2, left 3, down 2 is at -2, -4. And then 3, 2, left 3, down 2 is at the origin. And 4, 2, left 3, down 2 is at 1, 0. So now we want to draw this same shape, right? These are rigid transformations. We have not changed the shape. We have a part of a line from -4, 0 down through -5, -5. Then we have this part of a parabola that goes from -4, 0, -3, -3, down to -2, -4, and then back up to the origin. And then it is a horizontal line to the right of the 0, 0. Now I want to use the same graph of f, and now we want to draw the graph of g of x, which is equal to the opposite of f of x. So remember here that the opposite of f of x, when the negative is on the outside, that is taking the opposite of y, and the opposite of y is going to reflect the graph across the x-axis. So remember that if x, y is on the graph of f, then the point x negative y is on the graph of y equals negative f of x. So let me label these points on the graph of f again. We have negative 2, negative 3, negative 1, 2, 0, negative 1, 1, negative 2, 2, negative 1, 3, 2, and 4, 2. So on the reflected graph, we keep x the same but take the opposite of y. So negative 2, negative 3 on the graph of G would be negative 2, 3. Negative 1, 2 would become negative 1, negative 2. 0, negative 1 would become 0, 1. 1, negative 2 is 1, 2. 2, negative 1 would be 2, 1. 3, 2 would become 3, negative 2. And 4, 2 would be 4, negative 2. So we need to draw the graph of this just flipped across the x-axis. And so we have this line that goes down through negative 2, 3 to negative 1, negative 2. And then we have a parabola that looks kind of upside down. It's going to start from this negative 1, negative 2 up through this 0, 1 up to the 1, 2, and then it's going to come back down and go to the point 3, negative 2, and then it's going to be a horizontal line segment, or ray rather, to the right of the 3, negative 2. Now we have the same graph, and we want to draw the graph of g of x, which is equal to f of negative x. So this time our negative is on the inside, right? So we have an inside change. To take the opposite of x is going to be a reflection across the y-axis. So recall, if xy is on the graph of f, then negative x, y is on the graph of f of negative x. Labeling these points again, negative 2, negative 3, negative 1, 2, 0, negative 1, 1, negative 2, 2, negative 1, 3, 2, and 4, 2. On the transformed graph, we take the opposite of x and keep y the same. So negative 2, negative 3 would be at positive 2, negative 3. Negative 1, 2 would be at positive 1, 2. 0, negative 1 will actually stay at 0, negative 1. 1, negative 2 would become negative 1, negative 2. 2, negative 1 will become negative 2, negative 1. 3, 2 will become negative 3, 2. And 4, 2 will be negative 4, 2. So this time we're flipping it horizontally, right? Reflecting it horizontally. And so we're going to have our horizontal line segment coming again from the negative 4, 2 and the negative 3, 2. And then we're going to have this parabola that goes down through the negative 2, negative 1 to the negative 1, negative 2, up through 0, 1 to the 1, 2. And then this line that goes from 1, 2 down through the 2, negative 3. And then one more, now I have a different graph. We have the graph of a new function y equals f of x shown. And we want to draw the graph of g of x, which is equal to 2 times f of the quantity x minus 1. So understand there is an inside change and an outside change. The inside change of minus 1 tells us that we will shift the graph right 1 unit. And then the multiplier of 2, right, since that 2 is greater than 1, we're going to vertically stretch by a factor of 2. And so what this means, if the point x, y is on the graph of the original function, then on the graph of g, we're going to shift right 1 unit, which means we will increase the x values by 1. But the y values are going to be multiplied by 2. So we will shift right by 1, which adds 1, and multiply the y value by 2. So let's look at our original function and see what are the points on this graph. We're given -4, -4, and then -2, -3, and then -1, -2, 0, -1, 1, 0, 2, 1, and then 4, 1. So we have this line segment that goes from -4, -4 to -2, -3, and then a piece of a line that goes from -2, -3 all the way up to 2, 1, and then a horizontal line segment from 2, 1 to 4, 1. So for each of these points that we've identified, we need to perform this operation where we shift it right 1 and stretch the y by a factor of 2. So this means this point -4, -4 is going to move right 1, but then we have to multiply the y value by 2. So that's going to take us to -3, -8, which unfortunately is a little bit off my screen. 2, -2, -3 is going to go right 1, but then multiply the y value by 2. So that's going to be at -1, -6. -1, -2 is going to move right 1, and then multiply the y value by 2. So that's going to be at 0, -4. 0, -1 moves right 1 and multiply the y value by 2. So that's going to be at 1, -2. 1, 0 moves right 1, and when we multiply the y value by 2, we just stay at 0, so that's going to be the order pair 2, 0. Then 2, 1, we move right 1 and multiply the y value by 2. That takes us to 3, 2. And then 4, 1, we move right 1 and multiply the y value by 2, which takes us to 5, 2. And so we would draw the shape of this graph. So again, that line segment that goes through -3, -8 to -1, -6. And then we have a line, piece of a line that goes from -1, -6 through 0, -4, through 1, -2, 2, 0, up to 3, 2. And then we have the horizontal piece from 3, 2 to 5, 2.